Hi everyone, today we'll be solving the LeetCode daily challenge, and today in this question, so I'll try to solve this question as if I'm in a real interview. So let's get started. And so here the question is given to us. It is called find the duplicate number, and uh, here it is given that given an array of integers containing n plus 1 integers where each integer is in the range of 1 to n inclusive 1 to n inclusive, there is only one repeated number in nums. Return this repeated number. You must solve this problem without modifying the array nums and use only constant extra space. So let's have a look at the examples. With the first question, we can see that there are 5 elements, so the range becomes 1 to 4, right? And there is one repeated number, and this repeated number is 2, so we need to return 2. As similarly in the example 2, 3 is repeating, so we need to return 3. And in the example 3, if you see that here it is given that there is only one repeated number, it does not mean that the same number cannot repeat in the array. It is specified that only the only one number will repeat, but it does not mean that uh, it will only repeat once. So this is what the question says, and as you can see that here the constraint are given as that n can go to 10 to the power 5. So obviously if you write a brute force solution which uses two loops, it would give you a TLE, and all the integers in nums appear only once precisely. This is given that the numbers can appear 2 or more times. Here is the follow-up. How can we prove that at least one number duplicate must exist? So this is quite obvious. I'll prove it later. And can we solve the problem in linear runtime complexity? So these are the follow-ups, and let's try to think it through the question, right? And let's think about the very brute force approach. What would be that? And it could be that you, let's say, take this example, right? And in this example, we try running a loop which travels through this vector, and for every element I run another loop which will be a nested loop and try to find this element in this nested loop, right? And if I am able to find, I'll return that element. So in this case you will have to use two loops which would result in a of n square complexity, which will give you a TLE. And what would be the space complexity? It would be O of 1, because you are not using any extra space. And let's think about how can you improve it. And the other way of thinking it as, you can sort this vector. You can write it as 1 2 3 3 and 4, right? So this would be a better approach if you think, and this was the brute approach. We have sorted the array, and then we can either use linear search, right, comparing adjacent elements and find the one if these two matches each other, right? And if it does, if any adjacent elements like array of I becomes equal to array of I plus 1, if this condition is true, then you should return array of I, or you can return array of I plus 1 as well, but this will give you the answer, and the complexity will be n log n for sorting, and depending on what you use, either you use linear search, then it would be of n, or otherwise it would be of log of n if you use the binary search, right? But here is a violation that we have done, that we have modified the input, and we are not supposed to do that, because in the question it is clearly written that you must solve this problem without modifying the array nums, and here we have modified the array. But still, this is an approach which you can tell, and you can tell the interviewer that this approach will modify the array, right? And then you can tell this. And similarly, so this approach would run fine, and this will get accepted, right? This will get accepted. And let's think about other approaches as well. So there exists a technique called cyclic sort, right? This again is a sorting algorithm, and it sorts the array in O(n) time, and it is specifically, you can apply it to those questions wherein the range is given to like something like this, 1 to n, or let's say 0 to n, right? In these type questions wherein the range is given for the elements like these, you can apply cyclic sort, and this will sort the array in of n time complexity, and as for the space complexity, it will not require any space, so that would we do of O of 1. And similarly, then you can apply linear search and whatever you want, linear search or binary search. The only improvement from above approach, the only improvement that we saw here is the sorting, like here it was taking n log n, and here it is taking of n for sorting. But the questions but the problem remains the same, that we are modifying our input, which we should not do. And let's see if there is any other approach we can think of. And if I show you the question again, we are just trying to find the duplicate number, right? So why not use an unordered map, or maybe map you can use, but I'm taking unordered map, right? Just count the frequencies for every key that exists, like 1 is appearing 1 time, 2 is appearing 1 time, 3 is appearing 2 times, and 4 is appearing 1 time. And then what you can do is you can traverse through the map and check if any key, right, if any key, so if MP of any key is greater than 1, that means the number is repeating, and then you can return that key itself, right? But here also, even if we are not modifying the array, but we are violating the other condition, that we should do the question in constant space. And till now we haven't found a solution that except a brute force solution which does the question in constant space. And right, yeah. And also the above solutions were not like, if we consider the follow-up question, they are not doing in a linear time complexity, they are taking more than that. So let's come to the actual solution, which is using the slow and fast pointer, right? Slow and fast pointer. Now here is the thing, like in the linked list questions, we have a question wherein we were supposed to find if there exists a link cycle or not in the linked list. And similarly, we also had a question, the follow-up question, that if the cycle exists, then return the starting of the cycle, which means this thing, right? And the similar pattern we can use, we know that slow and fast can be applied in the linked list, but slow and fast pointer, the concept of slow and fast pointer can also be applied in this question as well. And like for cycle detection, and the repetition here is referring to the cycle detection. So what we can do is, so one thing that is allowing us to apply the slow and fast pointer method here is the range that is given to us, which is 1 to n, right? And you know, there is there is the, if you try to write the elements of the actual array, it is saying that there will be n plus 1 elements. So let's say there will be 5, there will be 6, there will be not 0, there will be 1, there will be 4, and up to, let's say there will be whatever will be the n, and then extra element also exists, that the n plus 1 element, right? So n elements are here and the extra element is also here, right? But it is wrong to write this, wait, and then the extra element is also here, you know, but this extra elements that comes will be from this range itself. So like even if all these numbers were unique, then it is obvious that this number has to come from this, and so it is proved that there will be repetition. So the follow is proved, and this range also allows us to use the slow and fast pointer method. So how do we do that? In the linked list, we were using the next pointer to move through the linked list, and also we had a loop. Right? So we were not going to any out of bound, and whenever we used to detect the link, the loop, right, or cycle, then we used to write a condition like while fast next pointer. If these two pointer existing are exist, then we run the loop, right? So how do we make sure the similar termination condition in the case of vectors or arrays? Because if we keep using simple array indices, right, we will go up, we'll go next, and after some time we'll go out of bound, right? So here in this question we will make use of the elements itself, and we will use those elements as the indices. So I will take a slow pointer which starts at the starting point, which is nums of 0. So here you can see I didn't take it as 0, I did take it as the first element, and I take fast, which is also nums of 0, right? And here since we don't have any, you know, checking next pointer if next exists or not, right, in the case of linked list, you need you could have simply doing next, and you would simply go into loop, but here you cannot do that, because if you do next, your loop will end, right? Your loop will end because it will go out of bound. And if you it is possible that like in the case of linked list, we used to cycle through now, then we used to find a point where slow and fast meets. But if you do like this loop will end, right, and the question will end. How will you be able to meet at some point? So in here we use a do while loop. So we say that at least let it run for once. So we will move slow by 1 pointer. So we will do slow equals to slow goes to next point, that is nums of 0, right? Or what I could have done is could have write slow as nums of slow. Yeah, this is the correct way. This is not the correct way to write. It is actually for the very first step it is true, but no. So what you do is you move only one time, and for the fast you move by 2 steps now. So you do nums of fast. So this is how you move two steps at a time, and and you and you do it till while you don't while slow and fast does not meet each other, right? So you do something like this: initialize slow and fast from the very first element, and then you do a run a do while loop wherein you move slow pointer by one step and you move the fast pointer by two steps. This is how you move the fast pointer by two steps, by using nums bracket nums fast, right? And then you um, and then you add a termination condition like while slow not equal to fast, and when the control reaches here, by that time slow and fast are at the same point, right? And like in the case of linked list, like you used to do, like here if it is linked list, and let's say here also a point exists, and let's say here your slow and fast matches each other, mates each other, then you used to take one of the pointers, right? Just take one of the pointers and move it to very starting, and then fast has gone there, right? I just erased the fast pointer, and then you try to move only one step at a time, both move both pointers one step at a time, and eventually you will meet them, and now when they meet at some point, this point will be our starting of the loop, and similarly here it will give us the repeated element in the array. So what do I need to do now? I'll run a loop while, and first of all I'll move fast to the very starting. Fast equals to nums of 0 or nums of 0, yeah, and I'll write while slow not equals to fast, and I'll write slow equals to, I have to move it by one step only, na, nums of slow, and fast also needs to move by only one step. Fast equals to nums of fast. Okay, and after doing that, now when the control reaches here, it is obvious that slow and fast have meet each other, and then at that point we are on the repetition or starting of the cycle. Then in that case we just return any of those, like you can either return slow or you can either return fast. So I'll just return slow itself, right? So that's how it works, and that was the explanation of it. I'll just code it, and I'll just show you the code right away, or should I code? Let's code it, right? Like I said, I'll try to take two pointers, which is int slow, which I'll initialize with the nums of 0, and I'll also take int fast, which I'll also initialize using nums of 0. Then I'll run a do while loop. I'll move slow by only one step at a time, and I'll move fast by two steps at a time. And I'll also add a termination condition, slow not equals to fast. So then when they meet for the very first time, that's when we are sure that the cycle exists for sure. And so if the cycle exists, now we take our fast pointer to the very starting, and then we try to move them one step at a time, and if they match now, then we say that the point there where they meet is the starting of our cycle, or in the case of array it is our repeating number. So I'll simply run this up and let's see if it is working fine. Let's submit it, and it is accepted. So thanks for watching. As for the mathematical proof of it, like there must exist a cycle or the follow-up question. For the proof, I might make some another video. So yeah, thank you for watching. Bye.